Hello children, I think you must have seen my previous videos on trigonometry. Today I am going to do this video on introduction to trigonometry. This particular video was long due, but because of some problem I was not able to complete this video, but today I have already planned that I'll complete this video and I'll post it so that you'll have serially, like in the first year you have the introduction to trigonometry, then in the second part you will have the trigonometry ratios of specific angles that you have already done. Then in the third part you have the complementary trigonometry ratios of the complementary angles, and then you have the identities. So today I will start with introduction to trigonometry. Now you all must have known about triangles, various types of triangles. There are how many types of triangles are there? There are so many triangles you have this triangle where you have an isosceles triangle, you have a scalene triangle, equilateral triangle. One type of triangle is there which you all must have studied. It is known as the right angle triangle. Now what is a right angle triangle? In a right angle triangle you have one angle which is 90 degree, and whenever there is a 90 degree, if you find a square type of thing over here, not this arc sort of thing, if it is an arc, then it must be having some different angles, but if it is a square like this, it means that it is a right angle triangle, and it is right angled at this point. Suppose ABC is the triangle, and you have the square type of form in near B, so this triangle is right angled at B. Okay, fine. Now what is the use of, now you'll be using trigonometry for this right triangles. Okay, and what is trigonometry? I'll come to that later on, but first let me come to the application. Suppose you have gone to Delhi, okay, and you have the Qutub Minar over there. So let me just try to draw a Qutub Minar. Okay, does it look like one? Okay, if you say yes, then I'll be the happiest one. Okay, anyways, so you are at the top point over here. Suppose you are here in the Qutub Minar, and you are not here. You cannot go there upstairs. You know, you are not allowed. Sorry. You are somewhere here. Okay, and you are just from here, you are looking at the Qutub Minar, and this is the top point of the Qutub Minar. Okay, so from here you are looking at the Qutub Minar. Fine. From here, on the basis of trigonometry, you can calculate what is the height of the Qutub Minar. Not the exact height, but you can calculate the approximate height of the Qutub Minar. And what is the condition? Condition is you should know what is this particular distance and what is the angle it forms with the base. Then you can find out the height. Okay. Or some other case, like you are in the third floor of your building. This is your building. Okay, and you are in the balcony and you are in the third floor of your building. Here somewhere you find a kite is lying on the floor. Okay, a kite is lying on the ground. So you are seeing, so from here you find the kite here on the floor. Now you can approximately tell what is the distance of this kite from the building. You can very well say what is the distance. How? If you know what is the height of this building, and if you know how much angle you form here, okay, when you look at the kite, then you can very well measure the distance of the kite from the building. Okay, these are the few examples of trigonometry. Now see the word trigonometry. trigonometry. It is divided into three parts. First, tree. Tree means try. It means three. Okay. Then you have this word called gone. Gone. What is the meaning of gone? It means sides. Okay. Then you have the third one, metron. METRON. What is metron? It means measure. 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 Trignometron. So trigonometron. It is trigonometry. Tri for three, gon for sides, and metron for measure. Okay. Now, in fact, it is the study of the relationship between the sides and with the angles. What is trigonometry? It is the study of relationship between the sides with the angles. Clear? Even today, most of the technological advanced methods used in this engineering and physical sciences are based on trigonometrical concepts. Okay. Astronauts also use this trigonometry to find out the distance between the stars and the planets from the earth. Okay. So this is a very small introduction on trigonometry. Now we go to the trigonometry ratios. Trigonometry ratios. Okay. What are the trigonometry ratios? Now let me first form a right angle triangle. In this right angle triangle, suppose you have this A, B, C is the right angle triangle. Okay. No, now it is right angled at B, as I told you. So you will make a square sort of thing over here. And if this is the side, now this right angle is carried by AB and AC. These two are the arms which hold this right triangle. Suppose I am talking about, now what is the side opposite to this 90 degree? It is AC. So this is known as the hypotenuse. NUSC, hypotenuse. What is the side which carries the 90 degree here, or which is opposite to this C? It is your base. It is known as the base. And what is the side that carries the right angle, that it carries the 90 degree, but it is opposite the angle A or adjacent to sides angle C? Then it is known as the perpendicular. Okay, so you have hypotenuse, base and perpendicular. So we have this triangle ABC, hypotenuse, perpendicular and base. Okay, now based on these hypotenuse, perpendicular and base, we will find out the trigonometry ratios. So first one is your sine of angle A. That means I am talking about this angle. Okay, so the angle which is opposite to the perpendicular. Sine A, it is the side opposite to angle A by hypotenuse. That means perpendicular by hypotenuse. Okay, that is sine A. What is cosine A? Cosine A is given by side adjacent to angle A. What is the side adjacent to angle A? It is AB, which is known as the base by the hypotenuse. So base by hypotenuse. Fine. Now tangent of angle A. What is tangent of angle A? It is side opposite to angle A by side adjacent to angle A. That means perpendicular by base. Perpendicular by base. You have to remember these three: sine, cosine, tangent. And next, I'll keep the paper over here, and next we will go to cosecant. C-O-S-E-C-A-N-T. I'm spelling it, okay? Cosecant. Cosecant of angle A is equal to 1 by sine of angle A. Okay, so it will be how much? Hypotenuse by perpendicular. So I'm writing hypotenuse by perpendicular. Fine. Then you have secant of angle A. It is 1 by cosine of angle A. So 1 by cosine, cosine is base by hypotenuse. So you will have hypotenuse by base. Fine. Then you have cotangent of angle A. What is cotangent of angle A? It is 1 by tangent of angle A. So it will be just the reciprocal of this. That means it is base by perpendicular. Okay. Now based on this particular diagram, I am going to write the this is the formula. So let me name the base and perpendicular. So sine, I will write it as just S-I-N-E. Sine can be written as sine A. What is perpendicular? Perpendicular is BC. What is hypotenuse? It is AC. What is cosine? Cosine can be written as cos angle A. I am not putting the angle sign over here. I am just writing A for convenience. Okay. So what is it? The cosine A, it is base by hypotenuse. Base is AB. So it is AB by hypotenuse is AC. Fine. Then you have tangent of angle A. Tangent of angle A is written as tan A. What is tan A? Perpendicular by base. That means it is BC by AB. Fine. Then I am going to this. Let me finish. I have finished with this paper. Now I am going to cosecant. Cosecant is written as cosec A. Cosec A is the reciprocal of sine A. That means you will have it as AC by BC. Then we have secant A. Secant A can be written as sec A, which is a reciprocal of cos A. That means it can be written as AC by AB. Then cotangent of A. It is reciprocal of tan A. So it can be written as cot A. Cotangent is written as cot, and reciprocal of tan, that means it is AB by BC. You have now got sine, cos, tan, cosec, sec and cot. Okay, these are the ratios. Now we will straight go to the examples of the class 10 book. Okay. In the first example, by using this trigonometry ratios, okay, in the first example, you have given tan A is equal to 4 by 3. Find the other trigonometry ratios of angle A. Now, what is angle A? Let me first draw the right angle triangle. Okay, this is A. This is B, this is C, it is right angled at B. So tan A is 4 by 3. What is tan? What is tan? Tan A. BC by AB. That means it is given BC, it is 4 and AB, it is 3. Okay, you have to find out sine A, cos A. Okay, these are the basic ones. So if it is asking that find the other trigonometry ratios, then it means that you have to find sin A, cos A, then cosec A, sec A and cot A. That will be easy, because if you find sine and cos, then you can find the reciprocal. So let us first go to sine A and cos A. For that, you have to know what is the hypotenuse. As this is a right angle triangle, so first you find the hypotenuse by using Pythagoras theorem. So AC square is equal to AB square plus BC square. So AC is equal to root over of AB square is how much? 3 square plus BC square is 16, or let me write over here 4 square. So that gives you 9 plus 16, which is root over of 25. So AC is equal to 5. That means you have got the hypotenuse as 5. Now can you find out what is sine A? See, sine A is BC by AC. Sine A is BC by AC. BC is 4 and AC is 5. Got it? What is cos A? Cos A is AB by AC. Okay, what is AB? It is 3. And what is AC? It is 5. So you have got tan, you got sine, you got cos. What is the reciprocal of cos? It is sec. So what is sec A? It is reciprocal. So I can simply write it is 5 by 3. What is cosec A? It is reciprocal of sin A. So it is 5 by 4. And what is cot A? It is reciprocal of tan A. So it is just 3 by 4. Finished. Example 1. Was it easy or not? I think it was damn easy, isn't it? Okay. Now let me go to the second example. In the second example, if angle, it is given, there are two, this is example 2. You have two triangles over here. Okay. These are the two triangles. It is named as A, B, C and P, Q, R. If angle B and angle Q are acute angles such that sin B is equal to sin Q, then prove that angle B is equal to angle Q. How will you do it? So let us use, it is given sin B, our sin trigonometry ratios. So sin B, it is given, sin Q is given. So let us find out what is sin B. Sin B can be written as AC by AB. Okay, so AC by AB. What is sin Q? Sin Q can be written as PR by PQ. So it is PR by PQ. Okay. Now it is given that sin B is equal to sin Q. Let us equate it. So you have AC by AB is equal to PR by PQ. Okay. Let this I'll just simply interchange it. Let me write this as AC by PR. I'm bringing this one here and this one there, is equal to AB by PQ. Let it be some constant K. Some constant. Okay. Now using Pythagoras theorem, if you use Pythagoras theorem for BC, what is BC? BC is the base. Now BC can be written as AB square minus AC square. Why? Because AB square is equal to BC square plus AC square. So BC square is equal to AB square minus AC square, or BC is equal to root over of AB square minus AC square. Similarly, QR, I can write it as PQ square minus PR square. Fine. Now, let us go to BC by QR. What is BC by QR? Just put the values. AB square minus AC square by root over of PQ square minus PR square. Okay, fine. What is AB square? Tell me, what is AB square? AB square will be, see, AB by PQ is equal to K. So I can write AB square by PQ square is equal to K square, or AB square is equal to K. Will I write it over here? See, AB by PQ is equal to K, or AB square by PQ square is equal to K square, or AB square is equal to K square into PQ square. So instead of AB square, I am writing as K square PQ square. Similarly, what is AC square? It can be written as PR square K square. So K square PR square. Okay, whole by, sorry, I forgot the square root, by root over of PQ square minus PR square. See, I wanted to cancel out this one. So this is the only reason why I have substituted this value over here. Now from here, I can take K common. If I take K square out, and the square root of K square will be K. So what do you have inside now? It is PQ square minus PR square by root over of PQ square minus PR square. So what do you get? It is K. So let us name this as equation 2, and let us name this as equation 1. So from 1 and 2, what do you get? I can say BC by QR is equal to K. So I can write AC by PR, this is PR, is equal to AB by PQ is equal to BC by QR. Okay, so by your now here you will be using the similar triangles. Now these two are similar triangles, so triangle ABC is similar to triangle PQR. So because these two triangles are similar, why? Because you have got this ratio AC by PR. AC by PR is equal to AB by PQ. AB by PQ is equal to BC by QR. So triangle ABC is similar to PQR. If they are similar, then angle B is equal to angle Q. Reason, as triangle ABC is similar to triangle PQR. So children, I think I'll finish this video with this example 2. For example 3, 4, 5 and exercise 8.1, we will have a new video for that. So I hope the concept is clear. I think it will be a little bit confusing for these similar triangles, but I'm sure that you must have done these similar triangles earlier, because in standard 9 you have done congruent triangles, and this is little bit similar to the congruent triangles. So based on this similar triangle, you have to prove that angle B is equal to angle Q. Fine. So it's bye for now. If you have any doubt, please write to me in the comment box.